Endogenous Longevity and Optimal Tax Progressivity by Bukatier and Stefan Rohrbacher, published in the Journal of Health Economics. Hello and welcome to this presentation of our recent results. I will present you the main results and the intuition in a nutshell in the next couple of minutes before I get into the details of the model in our study. So our starting point here is the observation that people who are richer, who have a better education, live longer in the United States. So this was pointed out by Christian and Pigeon Mars and Victoria's Rule. They even estimated the so-called longevity education gap, so by how much college-educated people live longer than high school graduates, and it's 4.8 years, an astounding 4.8 years in the United States. And therefore, as a politician, of course, the natural question arises, should we redistribute income from the rich to the poor, from the college-educated to the high school graduates, so that there's less inequality in life expectancy? Now, the early question, if we should redistribute with the help of income tax, has been analyzed in the optimal tax literature, starting with Smirnov in 1971, and they find that we should put higher income taxes, marginal income taxes on income for the rich, and vice versa, lower for the poor. And some authors like Zeiss have pointed out that the optimal tax schedule really depends on the income distribution, in particular on the fat tails of the income distribution on the very rich people. Now, what's the basic idea of this literature? Let me go to the whiteboard to explain this for you quite intuitively. So what we get here is utility as a function of consumption, and of course utility increases with higher consumption C, but at an ever decreasing rate. So we have a concave utility function. Now here we have consumption of the low income person, let's say the high school graduate, and here we have consumption of the high income household, let's say a college educated person. And associated we have utilities UL and UH here. And if we look at the average of these two utilities, that's average utility in the economy, our measure of welfare in our model here. Now, the main idea of redistribution is we take income from the rich, give it to the poor, so that they, well, if we have complete redistribution, so that we get equal income distribution, net income distribution, they enjoy the same consumption level C bar with utility U bar. And as you can see, U bar, the average utility then is higher than the average utility prior to redistribution. So this provides a rationale for redistribution of income with the help of income taxes. Now there's a drawback of this, and this is analyzed by Myers and Zeiss in the partial equilibrium analysis. They look at the labor market, partial equilibrium, and they analyze how the labor supply reacts. And they find, of course, labor supply by the rich goes down, the labor supply of the low-income people goes up because of the change in the tax rates. They have to pay higher taxes, they have to pay lower taxes, so that's why labor supply changes. Now, because the rich workers, the high-income workers, are more productive than the low-income workers, the low productivity workers, this results in a decrease in the labor as measured in productivity efficiency units. And therefore, in our model here, if we redistribute, well, in this case, the average consumption is not C bar, but it goes down further due to this reduction in efficient labor, so that they might end up here. And if you compare now these utility levels, well, in this particular case that I draw here, average utility prior to redistribution is still smaller than in the case when we redistribute and labor supply, effective labor supply declines. Now the next step, we have something like a general equilibrium models. So this literature is prominent in the late 90s, early first decade of this century. So let me show you this literature here. It's literature by Gustavo Ventura, Conessa de Krüger, Jonathan Heathcote, Katie Storrs-Lattin, and Jagan. And they show that optimal progressivity should be notably lower than in the US due to general equilibrium effects. So Conessa and Krüger find, for example, that we should have a linear income tax of 17% with fixed deductions of $9,400 in the United States, of tax exemptions of approximately $10,000. So it's much less progressive, the income taxes, than currently, meaning that the rich should pay lower taxes and the poor should pay higher taxes according to this general equilibrium analysis. Now, what's the difference between the general and the partial equilibrium analysis here? Well, in the general equilibrium analysis, they also look at the capital market, not only the labor market, but also the capital market. So what's happening in the capital market? Well, the rich have to pay higher taxes, so their net income decreases and they save less. The poor, they have to pay lower taxes, so their income increases and they save more. But the savings rate of the rich is higher than the savings rate of the low-income people. As a consequence, aggregate savings go down. And as aggregate savings go down, our investment goes down. And we buy less machines, less capital, capital K. And as a consequence, the productivity of all workers go down, total income goes down. And what we observe in our graph here is that consumption falls even further due to this general equilibrium effect in the capital markets. So we might end up here with the new C prime and associated average utility that is now lower than prior to redistribution. And that's the main idea of these papers. Well, there's a general equilibrium effect in the capital market that's not considered in the partial equilibrium analysis of Merles. And this general equilibrium effect results in an optimal tax schedule that's basically flat, where we have little increase in the marginal income tax rates for the rich people. So the rich should pay fewer taxes. And now comes our new argument, our new idea. We do not impose that health and survival and lifetime is exogenous, but we think it depends on how much people spend on their health expenditures, how much they spend on good food, on exercise and stuff like this, and it's related to income. So people with higher income spend more money on healthy food and on their health, on medical expenditures. Therefore, we can also interpret our curve here as a relational functional between health and net income. So people with net income spend more on medical expenditures and on their health and enjoy a higher health and hence a higher lifetime. So health is a proxy for our longevity. Now the same idea applies to this first generation redistribution models here. When we take away net income from the rich and redistribute it to the poor spend more on health, the rich spend less on health, and because we have a concave function here, the increase in health among the poor is higher than the decrease of health among the rich, and as the longevity gap shrinks, we have a higher average longevity. That's the rationale for redistributing in our model, our partial equilibrium effect. Now, but we also have a general equilibrium effect, and the general equilibrium effect is, well, if the rich live a shorter life, they have to save less for old age. They do not become 100 or 120 years, they just become 75 or something like this. And vice versa, the poor, if they have a longer life, they will save more. But because, again, the savings rate of the rich is higher than the savings rate of the poor, what we observe is that total savings go down. And again, if there are less savings, we consume less and we all spend less on health. So we do not end up here again on this point, but we move down so that average health and average longevity declines due to this general equilibrium effect. Okay, this is the intuition for the mechanism in our model, and now let me show you our results. First, labor income taxes in our simple model display a smaller degree of progressivity than the present US income tax. So our optimal taxes are lower than currently in the United States, meaning our results points to the implication that the rich should pay fewer taxes and the poorer should pay higher taxes. We also distinguish the case of endogenous and exogenous longevity. So when we endogenous lifetime and endogenous intuition, the mechanism that I've just explained, that a redistribution results in lower lifetime of the rich and longer lifetime of the poor, we find that this is an additional argument to decrease tax progressivity. So we find that endogenous longevity results in a more robust argument to even further decrease tax progressivity and let the rich pay lower taxes and the poor pay higher taxes. So our results reinforce the results by Ventura, Conesa, Krüger, and Heathcote, who all have exogenous longevity. And if we also look at health, that people spend part of their income on health and increase their longevity with higher health spending, we find, well, their result is even reinforced and that it's kind of an upper threshold on the optimal tax progressivity they provide with their analysis, because if you take endogenous health spending into perspective, then taxes should be even flatter. Now we also look at the welfare effects of our optimal tax code here, and we find, well, it's about $30 to $69 billion annually each year, and this interval, the upper and lower limit here of these estimates depend on the labor supply elasticity, so how strong your labor supply reacts to a change in taxes. There's a little empirical uncertainty, and we looked at the upper and lower value of this provided by empirical estimates. So as a consequence, we do not only provide an argument that the rich should pay lower taxes and the poor should pay higher taxes, but that the rich should also live longer than the poor. In fact, we started from the longevity education gap of 4.8 years in the United States, and we find it's even optimal that this increases to 5.1 years in our admittedly simple, highly stylized model. Now you can download this paper at the homepage of the Journal of Health Economics. This is open access article, and if you would like to receive the slides or the computer code that we used to compute this model, just send me an email, burkhard@vvuniaugsburg.de, and let me just show you the link where you get with this link here. So this is the homepage of our link here, of our article at the Journal of Health Economics, Endogenous Longevity and Optimal Tax Progressivity by Burkhard and Stefan Rohrbacher. And as I mentioned, this is open access, so you can just download the PDF for free. In the following, I will show you the most important modeling choices, the most important elements of our model, which drive our results. And I will show you our results in a little bit more detail. So let us get into our simple model here. It's a standard overlapping generations model with just two periods, young and old. And we have two households, the low skilled and the high skilled, which we somehow loosely identify with the high school graduate students and the college graduate students. And we find that the skill premium amounts to 150%. So that the wage of the skilled, of the college educated people is about 150% above that of the low skilled, and we will implement this into our model. Now, a lifetime utility is specified as function 1. It's additively separable in utility today and utility tomorrow. So we consume C today and D in old age, and we discount future utility by a discount factor beta. And of course, we weigh it by our survival probability psi if we survive until next period and are happy to enjoy a longer lifetime, and then we will consume consumption D in old age. In the first period, we are workers, so we are loosely identified with age 25 to 65. The first period, the second period, age 65 until age 105. And when we work, we get this utility from working, and that's captured by the additive third term on the right-hand side of equation 1, which is this utility from labor. And mu 1 is the fresh labor supply elasticity, which is a sensitive parameter in our model. We calibrated with a low value of 0.25. In fact, empirical estimates vary, and usually in macro literature, you use a value of 1.0, like Trabant and Uhlich. But we took this conservative estimate to provide a even lower threshold for progressive taxes, so that it's rather more optimal to redistribute. Because if labor does not react strongly, well, then a lot of redistribution might be optimal. So we are taking rather the viewpoint, the standpoint here, well, let's even formulate the model in a way that it's most favorable with regard to redistribution. But even then we get the result that it's optimal to redistribute little. Now our survival until the next period, psi of h, depends on health h. Now let me draw your attention to the specification of instantaneous utility from consumption. So we assume it's logarithmic. You see is LNC, the logarithm of consumption, which is also supported by the empirical evidence. And what's new here is we add a constant. This constant b is crucial. So let's assume that in many studies b is neglected, is set to 0. And that's fine if you have exogenous lifetime. But if you have endogenous lifetime, well, let's assume consumption is something like c is equal to 0.1. Then the utility from consumption is negative, meaning that if people live longer, well, they enjoy negative utility in the future, then it's really even bad to live longer. So most people would agree it's nice to have a long lifetime, and we also model this, and we need to include this in our model by specifying a positive constant b, so that you not get punished if you live longer, but that you get extra utility from living longer. So we have to calibrate this parameter b carefully, that living a longer life and a healthier life, well, it's a value and increases your utility, your lifetime utility. Now, health expenditures. Health depends on private health expenditures and on public health expenditures, X and eta. And the more we spend on the gym, on healthy food, on private health expenditure X, well, the healthier we get. Therefore, that's how we endogenous health function, and we calibrate this parameter gamma that captures the shares of private and public health expenditures in the health expenditure function in health as by 0.5. Endogenous survival is endogenous, so our survival probability psi depends on health, and we model it by the function 4, which is taken from the literature, epsilon, which governs the reaction of health, of the survival on health is calibrated equal to 0.2, and we calibrate psi 0 so that we have an average life of 84 years, as we find in the United States. And the final element here in our model, that's a progressive income tax. So we use a typical tax schedule that is often applied in computable general equilibrium models here. So our tax schedule is captured by function 5, which is a good approximation of the US tax schedule. And with the help of parameter θ1, we measure progressivity. So let's take an extreme case. Let's look at θ1 is equal to 0. Then we have that our taxes that we have to pay when our gross income is equal to y. Well, then it's equal to y minus θ0 times y, or y times 1 minus θ0. So we have a flat rate tax in this case if θ1 is equal to 0. And if θ1 increases, we get a more and more progressive income tax schedule. And in the United States, Kruger, Holter, and Stepanchuk, they estimate that θ1 is equal to 0.137, and we take this as our calibration of the model. And we calibrate θ0 so that the average labor income tax amounts to 28% as in the United States. Okay, we have a couple of parameters that we cannot observe directly, for example, the B here in the utility function, or the discount factor beta here in lifetime utility. Now, in order to calibrate these parameters, we use calibration targets. So we want, for example, to have an annual real interest rate of approximately 4%. Private consumption should be something like 67%, 2/3 of total income. The total health spending in GDP should be 12%, and public spending amounts to 55% in total health spending. And we have a longevity education gap of 4.8 years. So let's see how our calibration, how our calibration fit turns out. Well, here in this table you find the value that is implied by our model and the target. As you can see, we match a couple of characteristics very closely, for example, the real interest rate or the private consumption share. Our fit of the public to total health spending is less ideal. So public health spending in our model is 72% compared to 55% in the United States over the last 20-30 years. But in light of the most recent reform, Obamacare, the health reform taken by Obama, well, then we are very close to these values. So we match the health spending in the United States after Obama closely. What we do not get very close to is our longevity education gap. It's smaller in our model, 3 years compared to 5 years approximately. Well, that's because longevity, your lifetime, your health depends on many other factors than income and health. It's also in your genes. You inherit a couple of health foundations here from your parents, and so and for example, it matters if you, for example, are married. If you're married, you live longer. And we do not model all these factors, so that's why our longevity education gap is smaller than empirically. So our model is too stylized, and you have to keep this in mind, that you do not interpret our results one-to-one, and do not go to a politician and say, well, we need a flat rate tax today now in the United States because of the results by Bocater and Stefan Rohrbacher in the Journal of Health Economics. No, this is a warning. Our model is not perfect, but just shows the direction tax policy should go, and results should be interpreted if they are missing endogenous health and longevity. Now, these are the results in our model. This is how the variables in our model behave. So if we look at the labor supply, it decreases with increasing tax progressivity. So if you look at today's level, approximately 0.14 of θ1 in the United States, And there we fix the average labor supply equal to 0.3 in our model, in our calibration. If we go to a flat rate tax, well, labor supply increases from 0.3 to 0.312. So the labor supply increases by 4% if we go to a flat rate tax. This is labor supply hours. If we look at efficient labor supply, it's pretty much the same. And this holds for both skilled, unskilled, and the average. Now, if we use a less conservative estimate of the fresh labor supply elasticity, the labor supply elasticity that is used by, for example, Trabant and Ulich equal to 1, of course, then this value goes up, let's say, by a factor of 3 to 4, so it would increase to something like 0.33, 0.34 by a much more significant amount. We are using a conservative approach, and therefore our model is set up more favorable with regard to redistribution, but we nevertheless get the effect the result that we should redistribute less with the present income taxes. Our net income, if we increase progressivity, the net income of the high skilled decreases while the one of the low skilled increases, but average net income decreases due to the general equilibrium effect that I mentioned before. The total effective labor supply declines and aggregate savings decline. And this is also shown in this diagram where we look at individual savings of the high skilled and the low skilled, and average savings. Clearly, average savings decline with higher tax progressivity because of the general equilibrium effects I mentioned before. Our private health expenditures, well, if we increase tax progressivity, the high school graduates, the low skilled, have to pay fewer taxes and can afford higher health expenditures, so their health expenditures and hence their health and longevity increases, while the one of the high productivity college educated people declines, but on average health expenditures decrease, and so does life expectancy and longevity. Now I will show you some numerical results here. In the left-hand side column, you find the benchmark with a tax progressivity parameter θ1 equal to 0.137, implying aggregate income of 10.33, for example, and an average income tax rate 28%. That's how we calibrated the model, and a longevity gap of 2.77 years. And we can also decompose the aggregates into individual variables, for example, the income of the low skilled and the high skilled, 3.1 versus 6.9, the labor supply equal to 0.3, and the average tax rates, which are 34% for the low income people and 33% for the high income people. Next, we compute the optimal tax progressivity so that average lifetime utility is maximized. And this is for a much lower progressivity parameter. In fact, it even halves to θ1 star equal to 0.0642. So it's much closer, even halfway to the flat rate tax, which would be θ1 equal to 0. As you can see, total income increases, the longevity gap increases, and here you find the so-called consumption equivalent change, which is the utility gain, the welfare gain in average utility in the economy expressed in total consumption, which is equal to 0.91%. And if you take the consumption levels in the United States, total consumption in annual consumption, you find that this number 0.19 corresponds to $30 billion annually. That's what you get as a welfare improvement by going to the optimal progressivity θ1 star and go halfway to proportional income tax here. Now this has different effects on the low income and the high income people. So the lifetime utility of the low income people decreases by 3.2%, while the one of the high income people increases by 3.7%. Now, if we take health, survival, longevity is exogenous, we find that the tax system should be more progressive. Theta star equal to 0.0806. So it's much higher, the optimal tax progressivity, if we have exogenous longevity. And in this case, the utility loss for the low skilled is lower, while the utility gain of the high skilled is smaller as well. So we observe two results from this. Two main results. A decline in both the longevity gap and inequality comes at the expense of lower average lifetime and lower average disposable income. And the optimal income tax in our simple model displays a much smaller degree of progressivity than the present US income tax code, theta star equal to 0.0642 versus theta equal to 0.137 in the United States. So this amounts to a welfare gain of $30 billion. Now, if we also look at a higher fresh labor supply elasticity, which is also in accordance with empirical evidence, then we even get to welfare gains of close to $70 billion. Now, it makes a big difference if we have endogenous or exogenous longevity in our model. So we provide evidence that the results by Ventura, Conessa-Kruger, Heathcote, Sturluson, and Jagan are even biased upwards, so we should have even less progression if we endogenize longevity. And the rich should live longer, and the poor should live a shorter life. Now, these are strong results. Huh? Imagine you should tell the people in the United States, well, the rich should live longer and the rich should pay fewer taxes, while vice versa for the poor people in the United States, they should pay higher taxes and live shorter. Now, we, of course, checked this result for many sensitivities, it's really an astounding result here. And we introduced stochastic health so that people can get very sick in old age, where you find a lot of empirical evidence that the medical expenditures increase in old age. We looked at higher labor supply elasticity. We looked at a different health production function. So we looked at the sensitivity with regard to the substitution elasticity of the health production function. And we also included the transition dynamics after a change to, let's say, an optimal tax rate, where we changed to a more flat rate proportional income tax system. All our results are robust to these sensitivities. They are not robust to the welfare criterion that we used, so we used average welfare. But of course, if we use, for example, Rawlson welfare criterion, where we optimize the utility of the least favorable, the least happiest person in our economy, as you can see here with a more proportional income tax, the lifetime utility of the poor households falls. So of course, then it's not optimal to reduce the tax progressivity in the United States. So it depends on how much you weight the welfares, the lifetime utilities of the poor and the rich. And if you're some kind of risk averse, for example, introduce a lottery that people do not know whether they get born rich or poor, and if people are risk averse, well, they might rather go for more redistribution if they live under this wheel of ignorance that Rawls was emphasizing. And we also looked at increasing wage inequalities. So what we have observed is in the United States that wage inequality has increased over the last 20, 30 years in the United States, especially after the 70s and 80s, after many more people went to college and the skill premium, the college premium increased to 150%. Well, we looked at what's happening if the wage inequality increases further, for example, due to automation, artificial intelligence, and so on, which might favor the more skilled factor in labor. Well, in this case, we have also, this is a qualifier here, then we need to be more careful, then our results become less robust if wage inequality increases. So this already leads me to the discussion of our results. So our income distribution is very, very simple. We have just college, high school graduates, and we just have two kinds, but we do not really model the top 1% of the income distribution. So we have no Bill Gates in our model or Elon Musk, these kind of peoples, which perhaps we should take much more heavily. Our demographic structure is very simple, so we just have two cohorts, young and old. This is different from the general equilibrium literature that I mentioned to you by Kruger and by Heathcote, where they look at a much more sophisticated model with 60, 70, 80 cohorts. And then this allows for much closer modeling and much better modeling of the savings. And of course, with the help of savings, we can insure ourselves against negative income shocks, against negative health shocks. And this is absent from our model to a large part. Therefore, we issue a warning here, do not take our results one-to-one and apply it to policy recommendations, advice. We need to specify a much more large-scale, more sophisticated model to pursue such policy recommendations. And we have neglected other redistributive policies. So we just redistribute with the help of income taxes, but perhaps it makes sense to redistribute with the help of the health system, more public health expenditures. So like Obamacare, this was analyzed by, for example, Jung and Tran in the Review of Economic Dynamics, and they find that this increases welfare. So we did not look at health redistribution, redistributive policy with the help of health expenditures, public health expenditures, and we did not look at education subsidies. So perhaps it makes sense that you somehow provide easier access to university education so that a college student does not have to pay $50,000, $60,000, $70,000 annually, which for a European like me is sheer madness. We have no tuition in Germany, for example. And perhaps it makes more sense to redistribute with the help of the education system so that the access to college education is easier for low-income people. And there's a lot of literature, for example, Kruger and Ludwig, that points to, and Heathcote, that points to this kind of redistributive policy. Okay, so in conclusion, let me summarize. We get this result: the rich should pay lower taxes, the poor should pay higher taxes, the rich should live longer, the poor should live less. Well, this is a really extreme result, and you should interpret it carefully because our model is so highly stylized, but it points to an important implication. All these studies in general equilibrium or in partial equilibrium that somehow compute the optimal tax schedule, optimal tax progressivity, they imply that labor or income taxes should be much more proportional, much flatter than they are presently, and we give further support to this result. Our results re-emphasize the findings of this literature that income taxes in the United States should be more proportional and less progressive.